All right, let's talk about 2(1)b radical functions. All right, so what we're going to do here, this is the second part of it. We're just going to kind of talk about the radical parts of these power functions and graph and analyze those, and then solve radical equations. There's some things we have to look at on those. So a radical function is one that can be written in this form here. F of x equals n the nth root of x p, right? Where n and p are positive integers. Okay, so remember we kind of had that on the last section where you had those fraction exponents, and the denominator was what we squared. The other one was the root. So this is kind of how we're writing it in radical form. So if you remember, we can write it the same way. Just remember that n and p have to be positive integers that are greater than 1, and they have no common factors. That basically just means that they are simplified, fully reduced. So we kind of talked about like these in the form of, x to the p over n power, right? Where you then would take, so for example, x to the 3/5 power, right? So that would be the same as saying the 5th root, take the denominator here, the 5th root of x cubed, right? So we kind of looked at these yesterday in fraction form, and now we're kind of going to look at them as their radical form, okay? All right, so let's go down and work on these ones here. So first, we take a look at this radical one, and we'll kind of go through all the information that we have here. So on this one, if we let this be the radical, you can see your graph, what it's going to kind of look like. If n is even, again, just looking at the different types, if n is even, you're going to have a graph that looks something like that. Then your domain, if you notice, is going to be all positive numbers, and your range, because it won't go below the x-axis, and it won't go to the left of the y-axis. The x-y intercept should be 0. It's going to be continuous on the domain from 0 to infinity. No symmetry. It's increasing the entire time. And you have a minimum here that matters. And your end behavior is going to be getting larger and larger. So as it approaches infinity on the domain, your range will also be approaching infinity. If n is odd, so basically we're talking about the root. So if you have an even root, that's what it's going to look like if your root is odd. So 3, 5, 7. Now you're going to have some numbers that go below the x and y axis. So your range is going to be a little bit different. You're going to have a negative infinity, positive infinity, all real. So you're going to have x and y intercept at 0. Should be continuous through the whole range, the whole domain and range. And then symmetry is, they have symmetry about the origin here. You can see that. It's going to be increasing again. It should be increasing the entire time with this graph. There is no extrema, because this would just be a point of inflection here at the origin, not a maximum or minimum. And then your end behavior is similar to what we've dealt with before. As it approaches negative infinity, f of x approaches negative infinity, and then the opposite. As it approaches infinity, f of x approaches infinity. Okay, so let's just practice one and take a look at what we do with that. And we will graph and analyze this function and show, describe all this stuff, okay? All right, so I went ahead and graphed this for you just to kind of save time here. And when we do this, it's kind of look like, and I think something similar to this. So just kind of shoot out that way. So, and again, you could plot points if you wanted to with the XY table. Again, if you don't have the graphing calculator, it's kind of a pain with this kind of a function here, but graphing calculator will help you do that. So punch that in and you get that graph. Okay, so let's talk about the stuff. Okay, what do we have to talk about? Well, we have to talk about the domain. The domain is, in this case, it's going to be 2 to infinity. As you can see, it includes 2 on x here, but nothing to the left of it. So it includes 2, so we have a bracket, and then seems to go towards infinity. Your range is going to be similar, except your range, if you look at it, includes 0 right here on y and then goes all up. As this number keeps going, it's going to keep going. So your range would be 0 to infinity. And then we look at some other things. You got an x-intercept, crosses the x-axis, or touches the x-axis, I should say, at 2. And then limit, we only really have to look at the limit of the positive domain here. So our limit would be the limit as x approaches infinity. The limit of f of x would then be infinity as well, because it just keeps getting further and further that way. It's continuous. Switch to red here. I don't know why, just because I want to. Continuous on the interval 2 to infinity. I should bracket that. Okay. 2 to infinity. And then it's increasing the whole time as well from 2 to infinity. Okay. So simple. Again, just graphing the radical, similar to what we did yesterday, but just with a different type of function with these radicals. So again, pointing out even and odd right here gives a different type of graph that we looked at before. Okay, so the next part is to solve radical equations. So you're going to be asked to solve them as well. And there's a step-by-step process here. So the first thing we want to do, we want to isolate the radical. So if we can, we want to get the radical isolated on one side. That way, then we can raise each side to a power equal to the index of the radical. So that means whatever root it is, we can raise that to it. So if it's basically, that's what we're talking about, like squaring both sides or cubing both sides, right? I'll kind of just write that in. Square both sides. Square both sides, or cube both sides, etc. Could be the 4th power, could be the 5th power, whatever. But that's what we're kind of doing there. And then we want to use inverse operations. All that is just an inverse operation. If you remember from algebra, it's just a fancy word for doing the opposite, solving. And then if we need to, we can factor as we need to go through it. Okay, so let's go through a couple of these. But first, let's talk about extraneous solutions. Okay, extraneous solutions, these are solutions that do not satisfy the original equation. That's why you need to check, must check all of our solutions involving radical equations. Pretty easy, you just plug it back in the equation and go. Okay, so pretty simple stuff to do there, but we have to check them because sometimes it doesn't work for the original equation. So make sure that you're plugging it back in to the original equation once you get your solutions. That's going to be important. Sometimes there's solutions we get when we factor, but they don't satisfy the original equation, so we have to kind of plug it back in. Okay, so let's work on some of these. We can solve each equation. Again, remember to check for extraneous solutions. At the end, we'll do that. Okay, so remember our first step is we're going to, if you have your notes available, you can kind of work through these. We're going to isolate the radical expression. So I'm going to add this 3 to the other side. So I'm going to have 2x plus 3 equals all of this in here, 28x plus 29. Okay, step 2 says to square both sides, right? So, or to raise it to a power. Well, this is the square root, so I'm going to square all of this. That should undo the radical, and I'm going to square all of that. So on the right side, I'm going to end up with 28x plus 29. And on the left side, squaring this. Now remember, it's a trinomial. It's 2 binomial squared. It's going to make a trinomial. So we should get something like 4x squared. Remember, you got a middle term. That's going to be 3 times 2x is 6x. And another 6x would make 12x because we factor that. We got to FOIL that out. Don't forget about that. And 3 squared would be 9. A lot of people forget about this middle term there. Okay, so as we continue rolling through, now we want to basically do inverse operations. We want to solve. So I'm going to I got to set it equal to 0. So I'm going to bring this 28x over. So I would subtract that. I'm also going to subtract this 29 and bring those over here, okay? And so now when I rewrite here, I'm going to have 4x squared minus 16x minus 20 equals 0. Okay, now let's look to factor. I can factor out a 4 here, take this 4 out, and I have x squared minus 4x minus 5. That equals 0. And then I'm able to factor from here. Okay, so scroll down just a touch. So now when I factor this out, I've got a 4, and then I've got x minus x. I think it factors out to x plus 1, x minus 5. So now I know my solutions. If I just kind of make an arrow up here, if I go x plus 1 equals 0 and x minus 5 equals 0, if I solve this, of course, then I'm going to get x equals -1 and x equals positive 5. So this is where I have to check for my extraneous solutions. So I'm going to check here and plug these into the original equation. Okay, so my original equation, remember, is 2x. It's all over here. So my original equation, 2x equals square root of 28x plus 29 and then minus 3. Okay, so I'm basically plugging in this -1 in here, and I'm also going to plug in the 5 in here to see if they work. Right, so let's check the first one. 2 times -1, that's going to equal the square root of 28 times -1 plus 29. I've got this minus 3 over here, right? So if I keep going here, I'm going to get -2 on the left. On the right-hand side, I'm going to have -28 here, plus 29 is going to give me the square root of 1, and then minus 3. Square root of 1 is 1, so 1 minus 3. So I'm going to end up with -2 equals -2. Well, that is a true statement, so that means that works. If it's false, then we could say that it doesn't work. So let's check 5 now. We got to check the other one as well. So we'll check 5. So using the same equation, I'm going to plug in 5 now. So 2 times 5, and this is the equation I'm using, equals square root of 28 times 5 plus 29 minus 3. Okay, so doing that math, I'm going to get 10 on the left-hand side. On the right, I'm going to get 28 times 5, I believe, is 140, and then plus 29, I'm going to get a square root of 169 minus 3. So that's going to be 13. And then as you work this out, you can see that both of those work. So that's good, which means that this solution is good as well. So both of those are solutions. Again, looking at extraneous solutions, if one of these didn't work, then you would just kind of put an X through one of those solutions. I don't think we have any extraneous solutions on our examples, because just kind of going through some different factoring types and different ways to do this. Okay. All right. So let's do the next one. So again, isolate the variable. That's number 1. So I'm going to subtract 8 from both sides. So I'm going to have 4 over here equals the cubed root of x minus 2 squared. Okay, so now remember we're taking and we're looking at raising it to the power of the index of the root. So we've got a cube each side, right? Because now I'm going to take all this and cube it, because we've got to get rid of that radical. So 4 cubed comes out to 64 on the left-hand side. All of this will wipe out and make it x minus 2 squared. Now from here, you could actually FOIL this part out and then factor it and all that stuff, but we have a perfect square on the left-hand side. So you could actually go one step further. Either way, you're going to get the same answer. If you'd rather factor it, you can, okay? But if I just use the square root principle and then take the square root of both sides here, because I have perfect squares, square root both sides, I will get plus or minus 8 over here. And then over here, I've got x minus 2 after square rooting it. Then I'm going to add 2 to both sides, right? So basically, I've got a -8 plus 2 and a positive 8 plus 2. So my solutions would then be x equals 10 and x equals -6. I've said those in reverse order. Okay, so those right now are my solutions, but we've got to check them. Got to check them. So we got to put them back in the equation. So we go ahead and do that, and we get 12 equals the cube root of x minus 2 squared plus 8. So I'm plugging these values in for my x, these values down here. So let's start with 10. So I go ahead, I'll use red to do it. Okay, 12 equals the cube root of, it's going to be 10 minus 2 squared in here plus 8. Oh, and I made a mistake there. Let's erase, because this plus 8 is not in the radical. Okay, so now what I've got is 12 equals 8 squared in here, cube root of 8 squared, which is 64. Okay, and I know I can do the cube root of 64, so I end up with 4 plus 8, so I get 12 equals 12. So 10 is a good solution. Okay, again, can't tell you enough because I don't think we have an example of one, but if they don't work out, then if you get a false statement here, then you would cross it out, wouldn't be good. All right, let's check numbers, -6, okay? All right, -6 in here, so I've got 12 equals square root of -6 minus 2 squared plus 8, that's the cube root. So then I go 12 equals, I'm going to get -8 inside the parentheses. -8 squared is going to be 64 as well. So you can see I'm going to get the same answer when I take the cube root of 64. Okay, 12 equals 12. So that means both those are good. Okay. All right, one more down here, and I won't even check it. I'll let you kind of do the checking, but we'll show you because just because a different type of solving. So in this case here, we can go ahead and square both sides right away because there's a radical on both sides. So if I go ahead and square all of this, though, that's the tricky part. I got to square all of it. So on the left-hand side, yes, our radical is going to go away. But on the right-hand side, remember, you're basically saying 1 plus the square root of 2x minus 12 times 1 plus the square root of 2x minus 12, and you'll have to FOIL that part. So then it gets a little crazier. We know that the 1 times 1 is going to be 1, and we know our outside term is going to be this squared, which is going to get rid of that. So you'll have 2x minus 12, but in the middle, it's where you've got to do this times this plus this times this, the inside and outside terms, which is actually going to give you 2 of those, and we can't really do that math, so it's 2 times the square root of 2x minus 12. So we didn't really succeed in getting rid of all the radicals, but we will eventually. Now we want to isolate that radical. So we've got to isolate this piece here, which means I'm going to move all this other stuff to the other side. So I'm going to subtract 2x, add 12 over here, subtract 2x, add 12. I'm actually going to subtract another 1 too because of that. So I'm just going to clean it up for you, just doing the algebra just to isolate this piece here. So now on the left-hand side, I end up with, let's see, negative x plus 12 equals just the isolated piece now, 2 times the square root of 2x minus 12. Now I can go ahead and square both sides, and because I've got the radical isolated. But it gets a little tricky here because, yes, I've got to square all that. And this, again, becomes another FOIL situation where I have to do that. I have to kind of square this whole thing. So I end up getting x squared minus 24x plus 144. And then on this side, finally, the radical is gone. But I do have to square this too. So I end up with 4 times 2x minus 12. Okay? So continuing on. Now, on this side, of course, I'm going to have, after I distribute, 8x minus 48 equals this over here. Okay, so continuing to just kind of isolate and solve, I want to get this equal to 0. So I'm going to bring this 8x over by subtracting it. Add this 48 to the other side too. So I end up with, I think, x squared minus 32x plus 192. So that's going to factor. It's going to go to x minus 24 times x minus 8 equals 0. So now you know you can solve. You're going to get x equals 24 and x equals 8. I'm going to ask you to do the checking with that original equation so I can speed through and get done with this video. Okay, and then we'll check that, see if both of them work out. Okay, we'll see you in class. Bring your questions. Have a great day.